Hello friends, welcome to my channel Civil Structures. Today we will discuss the bending behavior of one-way slab and two-way slab. So, as we all know that there are basically two types of slabs. One is one-way slab and other is two-way slab. Okay. So, how we can distinguish this one-way slab and two-way slab? Let's see that if my Ly upon Lx ratio, if it is more than equal to 2, you can consider that slab is one-way slab. And for two-way slab, when Ly upon Lx ratio is less than 2, we can consider it is a two-way slab. Okay. Here, Ly will be the longer side of the slab and Lx will be shorter side of the slab. Okay, so why we call this one-way slab? Because I'm taking one example. Here is a slab, okay, and if this is my shorter side, I'm giving the name, it is Lx, and if this is a longer side, I'm giving name, it is Ly. Okay. Now, if I can assume my load UDLW is entirely on this particular slab as UDL in uniformly distributed load. Okay. So, my one-way slab will be bent in the shorter direction. Okay, you can see that. And if I'm taking two-way slab, okay, let me draw. This is Lx and this side will be Ly. Okay, then two-way slab. This slab also having W UDL kilonewton per meter square. Okay, so two-way slab will bend in both direction. Okay. As we see that one-way slab will be bent only in one direction, or we can say in bending in shorter direction. Or here we can see bending in both direction. Okay, now as in our one-way slab bending in shorter direction, that's why we provide main reinforcement in one-way slab along the shorter direction. Okay, I think this statement we already know that in one-way slab the main reinforcement will be in shorter span, as in along the shorter span. Okay, and along the longer span we will provide distribution steel. Okay, but in two-way slab, as our bending will be in both direction, we'll provide our main reinforcement along both direction. Okay, if I am considering this is my main reinforcement, so here both reinforcement will be considered as a main reinforcement. Okay. Okay, now let's understand why one-way slab will be bend only in one direction and two-way slab will bend in both direction. To understand this, I'm taking one slab okay, this direction I'm taking shorter one, so it is LX, and this I'm taking LY as in longer one. Okay, I'm also giving a name for each and every side. This one is A, B, C and D. Okay, now we can assume that total uniformly load distributed over this particular slab. Now consider two middle strips AC and BD of the unit width along LY and LX. Let me show you. I am taking this unit strips. Okay, AC and BD. Width of these strips are unit, as in 1, whatever will be the unit. Okay, now as per this, my WX will be the load carried by strip AC, as in along X direction. Okay, and WY will be the load carried by strip BD, as in along Y direction. Now as per this, we can assume our total load W will be WX, as in X direction, and WY. Okay, let me give the number of formula 1. Now as we know that W load is on that particular these two strips AC and BD. Okay, now if the load is on this particular strip, deflection will be happens. Okay, so let's calculate this deflection, but at what point? At center point. Okay, so let me take, there is a center point, give the name O. Okay, now we have to calculate displacement at this particular point. Now how can we find this deflection? Okay, so we all know the value of deflection when we have one simply supported beam subjected with UDL. And how much will be the deflection at center? I hope you all can remember that particular value. Let me tell you that your delta at center, I'm giving you the point C. Okay, it will be 5,384 W L raised to 4 upon E I. Okay, where my W is uniformly distributed load over entire area. L is the length of that particular area or strip, or we can say beam. E as in modulus of elasticity and I as in moment of inertia. Okay. Similarly, we have two strips along LX direction and one is along LY direction. So what will be the deflection at center along X direction? It will be phi upon 384 Wx. Okay, and the Wx is a load which carried by the strip along X direction. Then Lx raised to 4 upon EI. And what is center deflection along Y direction? Phi by 384 Wy Ly raised to 4 upon EI. Now let's equate this both equations. Then phi upon 384 Wx Lx raised to 4 upon EI is equal to phi upon 384 Wy Ly raised to 4 upon EI. Okay, so these values can be get cut. EI will be the, now Wx Lx raised to 4 is equal to Wy Ly raised to 4. Now what about Wx? Wx will be Wy into Ly upon Lx raised to 4. Now substitute the value of Wx. How we can find Wx? We know that W is equal to Wx plus Wy, which was our first equation. Okay, and we can determine our Wx will be W minus Wy. Okay, so let me put that equation in this equation number 2. It will be W minus Wy is equal to Wy Ly upon Lx raised to 4. Then W will be Wy plus Wy Ly upon Lx raised to 4. Then what is Wy is equal to W upon 1 plus Ly upon Lx raised to 4. Okay, and what about Wx? Wx will be W Ly upon Lx raised to 4 upon 1 plus Ly upon Lx raised to 4. Okay, so we have two equations now about Wy and Wx. Now let me assume the ratio Ly upon Lx is equal to 2. So if I am taking Ly upon Lx is equal to 2 and putting this value in this both equation, okay, then what about Wy? Let's calculate. It will be W upon 1 plus 2 raised to 4. Okay, and it will be 0.05 W. Now what about Wx? Wx will be W into 2 raised to 4, 1 plus 2 raised to 4, and it will be 0.95 W. So as per our rule that if our Ly upon Lx is more than equal to 2, then our slab will be considered as one-way slab. So as per these values, you can consider that when Ly upon Lx value will be 2, then the load carried by the Y will be much lesser than load carried by the X strip. Okay, so when there is a slab having Ly upon Lx ratio is equal to or more than 2, the load carried by the X direction, or we can say the load carried by the edges in X direction is much more than load carried by the Y directions. Okay, and that's why the bending will be happen only in one direction. Okay, as you can see, this is 95% more than the y direction value, and that's why we can see that the bending will be in or we can say along X direction. I think along will be the better word. In X direction, and that's why we consider it is a one-way slab. Okay, and that's why we provide main reinforcement along X, or we can say shorter span. Okay. Now similarly, let's see about the two-way slab. Okay, where I have to take my Ly upon Lx strip should be less than 2. So let me take 1.5. Okay, and what about Wy? Let's check. Wy will be W upon 1 plus 1.5 raised to 4, and answer will be 0.16 W. Then what about Wx? Then Wx will be W multiplied by 1.5 raised to 4 upon 1 plus 1.5 raised to 4, and answer is something 0.84 W. So in this formula you can see that in both direction we have load distribution. We cannot say this equal load distribution, but both direction will have some amount of loads. Okay, so we have to provide our main reinforcement in both direction. Okay, now let's take one another ratio to justify our two-way slab. Ly upon Lx will be 1. Okay, now let's see what if our Ly upon Lx ratio is equal to 1. About Wy, W upon 1 plus 1 raised to 4 upon is equal to 0.5 W. Okay, and about Wx will be W into 1 raised to 4 upon 1 plus 1 raised to 4. It is again 0.5 W. Now in this case we can easily understand that our load carried by the both direction are same. Okay, and that's why we have to provide our main reinforcement in both direction. Why? Because the bending will occur along both direction in two-way slab. So when bending will occur in both direction, and we consider this type of slab will be two-way slab, and we provide main reinforcement along both directions. Okay.